Hello everybody, hope yesterday's lesson went well, sort of diverging from the video lesson format for a day. Today we're back. I'm going to explain to you section 2.8, which is graphing linear and absolute value inequalities. Now, compare that to some of the things we've already covered. We have graphed y equals mx plus b, so that's a straight line, slanted usually, and y equals absolute value of x, that's that V shape. But these are equations. They have equal signs in them. Today, we're going to talk about what happens, or what about, when you have inequality symbols in those same, what we had done before as equations. Now they're inequalities. Now, we have done some inequalities on number lines. This is one-dimensional. It's like just an x-axis. And we know that when you graph less than or greater than, an open circle sort of indicates where your line or your arrow starts. When there's a less than or equal to, greater than or equal to, there's a dotted line. And then you shade or draw an arrow in one direction or the other, just depending on the problem. On the coordinate plane, the xy axis, so two dimensions, y-axis, x-axis, instead of just one dimension, like up here, we are going to be graphing our lines, slanted lines, or the V shape of the absolute value. We will be graphing that. And we'll be doing some shading, just like here we shade one side of the number line or the other. We don't really shade it in like coloring, we just draw or scribble a little. But an interesting thing to note is that when you have a less than or a greater than, what you actually graph is a dotted line. When there's a less than or equal to, greater than or equal to, you actually graph a solid line. So it's going to kind of be like what we've done before, but it's expanded into two dimensions instead of just one. We'll start with y equals mx plus b, so linear inequalities, and then we'll get to absolute values, let's see, down here. So if you're the type who likes to watch a couple examples and then stop and move on, you might want to fast forward and see a couple of these examples at some point as well. All right, let's get down to it. Oh, by the way, I'm going to start off not using Desmos, but to make things go a little faster, I will use Desmos to help with the graphing. It'll be your choice whether you're going to do things by hand or using Desmos. Okay, so starting with number 2. First of all, I notice that this is a greater than or equal to. So when I graph this, I'm going to graph a solid line. What I learned about graphing y equals mx plus b is you start on the y-axis with the b, so positive 4. Then the number in front of x is the slope, which you're supposed to think of as a fraction. So from this starting point, I'm supposed to go up 7, 1, 2, 3, 4, 5, 6, 7, and over 1. That's not practical here because look, I run out of graph. I mean, that kind of works. But you can also go down 1, 2, 3, 4, 5, 6, 7, and then backwards 1. And that will also give you 2 points to draw your line. So that is a very crooked line, but it'll snap into shape. So here is my line. So if this were an equal sign, oh, what did I just do? Sorry. There we go. I only meant to erase. Doggone it. I'm so clumsy. Okay. If this were an equal sign, we would be done. That would be the graph, move on. But this is an inequality. So what I want to do is find every y value that's greater than the x values when you multiply them by 7 and add 4. That might sound complicated, so let me explain it a different way. This line splits the graph into two sides, sort of the left/upper side and the right/lower side. I call it the lower side because technically it's below the angle of this line. This is above the angle of that line. So some of these points have y values that are greater than the x values, and some do not. So we got to figure out which is which. The primary way for doing this is to pick something called a test point. Pick any point you want. So this is where, if we were in a regular classroom, I'd ask one of you to raise your hand and give me the coordinates of any point anywhere. Since I can't do that, I am going to pick this point right here. The coordinates of that point are 2, 1. And I'm going to plug them into this equation, or this inequality, 2, 1. So that's an x value, that's a y value. 1 greater than or equal to 7 times 2 plus 4. If I work this out, I get 1 is greater than or equal to 14 plus 4, which becomes 1 is greater than or equal to 18. Is 1 greater than 18? Absolutely not. That means that this point does not satisfy or does not fulfill or does not work in that inequality. And what that means is if this one point doesn't work, none of the points on this whole side of the graph are going to work either. So they are bad, garbage, no good, whatever you want to call them. Pick a point on the other side. So let's pick negative 2, 1 and plug that in and see what happens. So I put a 1 here. 7 times negative 2 plus 4. I get 1 is greater than or equal to negative 14 plus 4, which becomes 1 is greater than or equal to negative 10. Is 1 greater than negative 10? Yeah, it's positive. 10 is negative. So 1 is greater than or equal to negative 10. That means that every point on this side of the equal sign, not just that one point, but every point will satisfy or fulfill or will work in this inequality. So your answer is supposed to be this graph. You don't necessarily have to graph that test point, but it's the solid line with everything to the left and above. Left, so this way is kind of left and kind of above. Every point in there is an answer. So that's what the answer is supposed to look like. Let me scroll down and check number 2 and make sure I didn't just mess it up. And there it is, the exact same graph. Solid line shaded on the left / above side of that solid line. That's what we're looking for. And you can see there's lots of examples. Now I'm going to show you how to speed things up a little bit. I'm probably going to do number 4 a lot like the way I did number 2. And then after that, I might accelerate and give you some tips and tricks to make it easier. Okay, first of all, this is a less than. There is no equal sign here. That means that I have to graph a dotted line, and that matters. You have to do that correctly. My y-intercept is negative 5. The slope is down 10 over 3. So can I go down 10 and over 3? Not very easily. I can go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then backwards 3. And that would have the same result as going down 10 and over 3. Gives me the same slanted line, but this time I need to draw it as a dotted line instead of a solid line. Now as you can see, this creates a lower side / left and an upper side / right. Which side gets shaded? Well, again, we pick a test point. Now what you might find is 0, 0 is a very convenient test point to use because 0 is just a darn easy number to do math with. 0 is less than negative 10 times 0. Well, anything times 0 is 0. 0 minus 5 is negative 5. Is 0 less than negative 5? No. 0 is greater than negative 5. If this point doesn't work, that means all of these points over here do work. Do you have to pick a test point just to make sure? No, you don't have to. You might want to if you're a little paranoid, like, oh my gosh, I don't know if I'm doing this right. So maybe I'll pick the point negative 3, 1. So what I'm doing right now, you might consider extra work just to be redundant. 1 is less than negative 10 thirds times negative 3 minus 5. 1 is less than negative times negative is positive. That becomes 30 thirds minus 5. 30 thirds is 10 minus 5. 10 minus 5 is 5. Is 1 less than 5? Yes, it is. So yes, this is the side that gets shaded, not this side. All right, so my graph should be a dotted line with a shading on the left / lower side of the dotted line. Check number 4. And there it is right there. So hopefully you get the idea for what's going on here. You either have dotted or solid lines, and you shade either above or below the graph. Let's look at number 6 and see how we can do this a little easier. Well, first, y equals x minus 4, since there's an equal sign there, is going to be a solid line Negative 4 is here. The slope is 1, which means as a fraction it's up 1 over 1. So I need to draw a solid line like this. Okay, one of the most time-consuming things is taking the test point, plugging it in, and doing all this work. So here's a little tip, a little shortcut that works when the y is isolated. It only works when the y is isolated, though. It doesn't work like in a problem like this one here, where the y is not isolated. So keep this in mind. When the y is isolated like this, y greater than, you shade above. Less than, you would shade below. So a greater than you shade above, the less than you shade below. That's a greater than, so I'm shading above it. That is probably the answer. If I ever get there. Scroll down. Number 6. Where am I? There it is. Solid line, greater than, shade above. That's not so bad. That took a lot less time than plugging in a number and then working it all out. You can do the test number, of course, anytime you want. But let me do that shortcut again on number 8, just to prove how easy it works. All right, this has no y-intercept, which means 0 is where it goes through the y-axis. The slope is negative 5/3. That means down 5 over 3. There's no equal sign here. That means I do a dotted line instead of a solid line. And then finally, less than, you shade below the graph. So that's it. That's what number 8 should look like. Less than, below, greater than would have been above. And there it is. Cool beans? Maybe. Maybe you don't like that expression. Forget I said it. I'm old. Okay. So there. Now, could I have done that on number 2 and save time? Yep. Greater than, shade above. Could I have done that on number 4? Yep. Less than, shade below. Don't think left and right when you do this. It doesn't really work that well because a slanted line, left and right, doesn't really translate that well. But above and below always works. Until you get to a problem like number 10. So to do number 10, you have 2 options. You can either leave it in standard form and graph it and do a test point, or you could minus 3x over to the other side and put it in mx plus b form and do it that way. And it's kind of up to you. Just for variety, I'm going to go ahead and leave this in standard form. Remember, to graph something in standard form, use the intercepts method. Take the x term, set it equal to 0. Now I know this is greater than or equal to, so just temporarily set it equal to. Divide by 3. Oh, you know what? This isn't going to work. I'm smart. Take the y term, set it equal to 0, and that only gives you 1 point. Normally the intercepts method gives you 2 points and you connect the dots, but this time, because it's a 0, that doesn't work. So guess what? Kind of foolish here. I'm going to go ahead and put this in mx plus b form. Y is greater than or equal to negative 3x. Okay, the y-intercept, there is none. That means it goes through 0. The slope is negative 3, which you treat as negative 3 over 1, down 3 over 1. There is an equal sign, so I need to do a solid line. So something like that. And because it's a greater than, I shade above the graph. So maybe putting it in mx plus b form is the smart way to go anyway. Let me check number 10, make sure I'm right. If I can ever scroll down there, take my time. And there it is. Solid line through the origin, down 3 over 1, shaded above. All right, let's... Nah. I'll hold off on that. This one, okay, if I want to put this in mx plus b form, this is going to take a little bit of work. Bear with me. X minus 3y is less than negative 12. If I want to isolate y, I need to minus x. Negative 3y is less than negative x minus 12. Now I need to divide both sides by negative 3, which means I divide everything by negative 3. There's a rule we've mentioned, maybe possibly you've forgotten, whenever you divide by a negative, you have to flip that sign around. Negative x divided by negative 3, the two negatives cancel. The x, remember, is assumed to have an invisible 1 coefficient, so that would become 1/3 x. And then negative 12 divided by negative 3 is positive 4. So here it is in mx plus b form. It's really important that that sign flips around because we divided by a negative. So if I want to graph this, plus 4 is here. 1/3 x is up 1 over 3. There is no equal sign here, so I have to graph a dotted line. And it's a greater than. I know it started out as a less than, but because we had to flip the sign, it's now a greater than. That means I have to shade above the dotted line. Let me check number 12. And there it is. Ta-da. Okay, so admittedly, I had to jump through a few hoops in order to graph this. Let's talk Desmos for a second. First of all, if I type in y equals 1/3 x plus 4. Do you see that I get the line? I graphed my line correctly. So that's a good way to check it. But I can go back to the original and type in x minus 3y is less than negative 12. Oh, not negative 12, negative 12. There it is, finally. And look at that. Now, I'm guessing you would have discovered this anyway. Yes, Desmos does have a less than symbol or greater than symbol. They're all on that keyboard there. And it shows you the dotted line, it shows you where it goes, and it even does the shading for you. So you probably would have discovered this on your own anyway. I guess I'm sort of spilling the beans. It's going to turn out that all of this hard work I've been doing, you can just have the calculator automatically do it. I prefer that you at least go through some of the mental work, process it, understand why it shades, where it shades, all that stuff. But in the end, yeah, you can really, I'm not going to say cheat, but you can really make this work easy for yourself. I'll put it that way. You can make it easy. And I'm not entirely against that. Let's look at number 14 now. 4x minus y is less than 0. And there it is. So it looks like I have a dotted line that goes through the origin and maybe 1,4-ish, 1,4, dotted line. By the way, I'm using a highlighter. I'm using this. If you're doing pencil and paper, oh, my dog just jumped up on my lap. Okay. If you're using pencil and paper, it's okay to just scribble for your shading. That's fine. I guess that's kind of bad where I scribbled, I covered up my dotted line. So if you're going to scribble, maybe do something kind of like that. You know what I mean? Make it clear that it's a dotted line, not a solid line. Use your pencil to shade in if you prefer. If you have highlighters, or if you're a neat freak, or if you're using your iPad to do this work, the highlighter function makes a fairly decent end product. So anyway, there's number 14. Let's check number 14. There it is, the same thing. So from here on out now, we have absolute values. And the calculator does these just fine. So y is less than negative absolute x minus 2 minus 2. Now, before I do this, I'm going to review just a little bit from the last couple of days. An absolute value function looks like this, a V shape. A negative flips it upside down, like this. A minus 2 here moves it down 2 units. That's a vertical translation. And a minus 2 here moves it to the right 2 units. The fact that there is no equal sign here tells me that I need to do a dotted line. And the fact that it is a less than right here lets me know that the shading has to be below the graph. So when I do number 16 on the calculator, you see how quickly I did that using knowledge that we've been building over the past few days and what I'm teaching you today. It all comes together to make it a person able to do some fairly complicated graphing and math in your head with almost no effort. It just takes knowledge. All right, so let me actually use the calculator to do this, though. X minus 2, and then outside here, minus 2. I'll refocus the graph, and there it is. It's the exact same graph. Check number 16. At this point, I shouldn't even need to check it, but I'll just be consistent. And there it is. So if you don't mind, even though you can use Desmos and get through these quickly, I am going to go ahead and use the skills that I've been asking you to learn over the past couple of days. So number 18, again, absolute value is the V shape. The negative flips it upside down. The minus 4 shifts it down 4 units, like that. The fact that there is no equal sign is going to make this a dotted line instead of a solid one. And again, well, this time a greater than shades above the graph. So above is all of this space up here. So that is what the answer should look like. A great goal would be for you to set for yourself would be to do exactly what I did, that you don't need to use the calculator to do this. You can rely on the calculator, but you are learning and achieving to a point where you just don't need it. That would be an excellent goal to have. And there it is. Yep, the vertex is at -4, just like mine. If you're the type of student who thinks maybe they'll go on to pre-calculus next year, or college algebra, you know, you're going to keep progressing higher and higher in math, to do it the way that I did it would be a great goal. All right, let's look at number 18 just to make sure I didn't mess it up, and there it is. All right, number 20, how many problems are on this? 22, so we're almost done. Okay, so again, y is less than or equal to, so this is going to be a solid line. Absolute value is a V shape. Minus 4 in the bars moves it to the right 4 units. Plus 1 moves that V shape up 1. So I need to go like this. And then the fact that it's a less than means I need to shade below the graph. So all down here should be shaded for number 20. Let me get rid of this graph and type that in. Y is less than or equal absolute value x minus 4 plus 1. And doesn't that look just like my graph-ish? All right, just to be consistent, we'll check it down here, and there it is, the exact same graph. All right, 22, and we are done. So absolute value, V shape. Negative, upside down. Plus 2 outside of the absolute value bars is up 2 units. There's an equal sign, so I draw a solid line, not a dotted line. Did I do dotted lines before when I was supposed to? Oh yeah, I did. Okay. Oh, started doubting myself. And then where do I shade it? Well, a greater than is above the graph. So I shade up here. Will Desmos give me the same answer? Y greater than or equal to negative absolute x plus 2. Yep, same graph. 22. Oh, come on. There it is. And done. Okay, so you see that you can graph and create these answers manually using knowledge, using calculation, using figuring. You see that you can use Desmos over there. You see that you can rely, at least on this bottom part, rely on skills that we've developed involving translations and reflections over the last couple of days. There's no dilations here, that's okay. All right, so do this assignment whether you're using the calculator, whether you're using your head, or whatever method you decide. That's sort of up to you. Just remember, the deeper you learn it, the better off you're going to be in the future. Okay, I'm going to stop there. Contact me through the normal means if you have questions. Otherwise, I will